Thank you, Arpita. Hey, everyone. How are we feeling so far? It is very early, so I understand if you're a little bit tired. We'll try to keep the workshop a little digestible, so that you aren't dying trying to follow all the instructions, but let's kind of go. We'll do a little bit of background. So thank you for the introduction, and welcome to the workshop. Hopefully the concepts will be broken down enough where you won't have too many questions. However, if you do, just raise your hand. If I look up, I will answer it immediately. But we also have a bunch of mentors who can come and help. So once we're on the code setup section, if you have a question or are struggling with something, mentors right behind you, they can come and help you out with at least the setup of your code. Cool. So I am Parth. I'm currently building a startup. We recently finished an accelerator back in like Mayish, and we work around AI agents, infrastructure, and tooling. And in my past, like through my different internships, as well as a little bit of full-time work, I was working on distributed systems and machine learning at places like Apple and Tesla, as well as Autodesk. If you do want to find me, that's my Instagram. It's Partzarine, just my name with an underscore. Or you can also grab me on LinkedIn if you have more work-related inquiries. If you think we're friends, you can grab me on Instagram. As simple as that. Cool. So we're gonna go into like a quick brief around what agents are. I know there were a few other workshops as well. So if you have attended them, great. You will know a little bit more. But for you guys who haven't done any agent stuff, that's fine. We're gonna be starting from scratch. And we're also gonna be doing an environment setup, and then we're gonna be building two types of agents. A simple one to first familiarize yourself with this repository and the framework. And then the second one is going to be a complex agent. Cool. So what are AI agents? So the way I think about AI agents is that they are something that can almost think in a way, and then they can conduct actions autonomously. So they're really good for things which you can't automate through pure code. For example, whenever you have to essentially build out an if statement, or as a human, when you make a decision about what you should be doing, you're taking into an account many factors. And so what LLMs allow us to do, so large language models, is that they're able to almost think on behalf of us, and they can take the next best step given an input. And previously, you'd have to, if you were building a similar pipeline, you'd have to have different machine learning models to pick which step to do. If you have a large pipeline, you'd have to have multiple models to be very good at picking between and discriminating between the next steps to take. So agents have these two kind of keywords called thinking and reflecting. And if you saw like the new GPT-4o1 launch, it also does both of those things. So before it gives you an answer, it is thinking and reflecting. And what thinking and reflecting really is managing of context. The way you use LLMs well is by giving them the right context to work with. If you give them bad context to work with, or if the prompt is bad, your answers are also going to be bad. And in general, agents just really help with reducing the amount of human intervention in pipelines. So if we were to break it down, relatively simple kind of diagram, you have an input goal or instruction that you get from a user or a predefined one. It could be either. The agent thinks, reflects, and then it acts and conducts an action. And it's basically looping that entire process until it reaches its goal. So the issue with this is when you give an agent the ability to do anything, for example, control your laptop, it is very unconstrained. And while it has safety issues, the amount of failures that you do get from a completely unconstrained agent keep rising. The probability that it would accomplish its goal gets lowered at each step. And so that's why I created Dagent, which is essentially directed acyclic graphs as agents. You do not need to know what a DAG is. It is okay. It's essentially just being able to set up workflows, in a sense, and being able to run those workflows through complete natural language. Sweet. So any questions so far? Perfect. Okay. So we're going to dive into coding. And first, we're going to go to this repository. So if you haven't, you can grab the hack pack off Slack. And it's over here under the announcements channel. And then the hack pack is going to have all the links that you need. And I clearly closed it, so let me pop it up again. Cool. So my plan is to walk you guys through the entire setup. If we spend a little bit of extra time on it, that's okay. But I want you guys to essentially be ready with everything. So first, we're going to just review the repository and kind of what we're building, and then we're just going to get into the setup of everything. So the first thing is make sure you have your hack pack open, because that's what we're going to have for all of our links. So we're going to open up our repository. Make sure you have Git installed. If you don't, you can technically just download the zip. That is okay. But we're going to pretend like we're doing a whole new install. So is this visible for you guys? A little bit bigger. Actually, I think I can zoom in. Never mind. There we go. So you want to do a git clone and then paste the repository name if you haven't done so. If you haven't done git before, just follow along. Then we will go into our directory. You don't have to follow all of these steps that I'm doing necessarily. If you want to just follow along and learn the concepts, that is okay too. Don't feel pressured in any way. And if you do run into issues, do let us know. Cool. So now we have our repository installed. We now want to go and see what is next. So the first thing we're going to do is install Rye. How many of you guys have used Python before? Okay, perfect. And have all of you used pip for package? Okay, basically everyone. So pip is like the usual dependency manager for Python. I am quirky, so I use Rye. And I'm making you all quirky too. So here's where you get Rye. If you're on a Mac, you can just use this. So that's what we're going to do. But if you're on Windows or any other platform, you can just install from the Rye link on the repo. So
the Rye link doesn't work when I say the on this curl command.
Oh, yeah. I think what you would want to do is just go to ryeup.com. I might have messed up the link. So that is rye-up.com. And you can download whichever one from here. So Linux and Mac OS are the same, so you can just run that curl command that's on the repository.
Stage. Yeah. I forget. It's the link works. It's just you need to update the command in your repo.
Okay. Yeah. Yes, you are correct.
If you click
Nice.
on the
Good find.
Rye hyperlink and follow the instructions.
Yes. Okay. So we're going to go to the RyeUp website, and we're going to find this curl command. I would have run into that issue anyway, so I'm glad we're finding it. And you just want to curl that, make sure you install everything. I'm not going to go with the installation because I already have it installed, and you can see that we should be good. Cool. So once everyone does have Rye installed, it takes a little bit of a second. What we want to do is essentially just do Rye sync, and it'll set up everything for you. So all your packages will get installed, all your build files, everything pretty much gets done for you. And what you want to do next is, if you have like used virtual environments before, you should be able to pretty much open it at the same time. And so, for example, we're using Playwright. So a way you can check is Rye list, and you should be able to see what all things you have installed. So we're using the Dagent framework, so make sure you have 0.08 when you do Rye list. How far are we? Like, are we following along? Are we on the Rye install? How many people were able to do the Rye sync? So that's this command. And did it work? Yeah, that's okay. Yes. that's okay. But everybody's able to get to the Rye portion, have stuff set up. If you don't want to use Rye, by the way, that's okay. It just makes it very, very simple. If you don't want to use Rye, you can pretty much install from this lock file. So you can do pip install -r requirements.lock. Should have probably told you guys that sooner, but needed to make you a little quirky today. So we do the Rye sync, and we can run this command to activate the virtual environment. Now, how many of you have some LLM API key? Okay, you have Olama. So there are separate instructions for that, but Olama works too. And we do have an example for that. But does anyone have Grok API key or any other ones? Okay, so we'll set up Grok because that'll probably be the easiest. I would recommend that you set up OpenAI at some point because they are very useful. And you can put $5 on there and get very, very good outputs. And all the models will be defaulting to GPT-4. So because we'll be using Grok, there's a couple extra examples that I will focus on that make sure you're updating the model name. So we can go and do Grok. So again, go to the repository, click on the link. And so I think I might already be signed in. So create an account. It's pretty quick. You can use your email. And once you're signed in, I believe the link is console.grok.com. Console.grok.com. Get an API key. So it should be under here. And it's verifying I'm a human. Great. I'm not fake. And once you have that, we want to store that API key. So the way we store API keys is that we run exports, and clearly it is showing stuff. But Grok API key, and then you'd put key here. And you'd be able to copy this key immediately after you sign up on the Grok account. There's one more setup that we do need to do, but I think I'll leave it for a little bit later, just for time's sake. And we'll get there when we get there. Cool. Does everyone have their Grok API key? No? Okay, we'll give it another few minutes. Oh, that's on the GitHub link. It should be, the hack pack is under announcement. And you at the front, I'm sorry I'm isolating you, but you're using Olama?
I was planning to, but I got a Grok.
Oh, cool. Okay, you can try both then, because you will have like a Grok API key as well as Olama. So you should be able to play around with both as we're doing the workshop. Cool. Okay, how far are we into getting this Grok API key? Do we have it set up? Hands, Grok API key. We're still waiting on a few people. Okay, we'll give it another minute or so, but we're gonna start diving into the framework and how these things are kind of structured. So I would highly recommend that when you are building with the repository, that you have two big resources, obviously the repository for this workshop, but also the repository for the actual framework itself. And I have given it some TLC because I want it to be decent for actual use. And so I hope I've documented it enough, but if not, you can always find me and bug me and tell me how bad I am. But the best way to honestly learn any kind of language or any kind of framework, especially when you're getting stuck and the docs aren't doing their job, is to just dig into the source code. The source code is a little wonky because agents are wonky. The reason I built Agent was because there was so much extra overhead when you wanted to build an agent from scratch. And things like LangChain or just other larger agent building tools just don't allow you the level of granularity that you kind of need when you're building very, very custom workflows. You have to fit to their model and their model only, instead of being able to wrap your existing code into an agentic database or into an agentic workflow instead. Cool. Grok. Hands. Grok. Okay, we're going to move on now. So you can follow along here, or you can just like look at the screen. But basically, Dagent is, again, directed acyclic graphs. What that means is that you have a bunch of nodes or steps which are connected, and these steps execute depending on how, depending on the decisions made by the LLM. So there's a few things here. Again, the idea is to structure agents into a workflow, and the agentic behavior here is when the LLM is picking what to run next. So we're going to be going over some terminology. Tool or function calling is a very popular term. Yeah, question?
So
Oh, okay. Yeah, we have tool and function calling. And if you do dive into the world of like LLMs and agents, it's something that you'll be hearing a lot more. And the easiest way to describe it is that a tool is literally just a function which an LLM can use. It is extremely helpful to have doc strings or annotations, which can help the LLM infer what is happening. And this is what I recommend for larger functions or tools that you're passing into an LLM. And we'll cover like some of the idiosyncrasies of why you need like good definitions. But again, going back to my point, at the end of the day, you need to manage context. And that is what we're helping the agent to do in the background. So more specific to this library, there's two big things. There's a function node and there's a decision node. A function node is exactly what it sounds like. It is a function that is being run. And when you attach a function node to a decision node, you can allow the LLM to pick between it. So the decision node is essentially where you're able to pick between a bunch of different functions and run it. And we'll just get into the code to like show you more of the little neat portions of it, but yeah. And the next big thing that you will need is like this previous output parameter in your functions, especially if they're being chained and you need to connect different nodes together. So this is kind of a little diagram for Dagent. And essentially, if you have a function node that you're starting off with, you can connect it to a decision node. A decision node is where like thinking happens almost, and it's able to pick the next step and use it as a tool in its repository. And you can also chain different function nodes. So let's say I don't need the agent to think at every single step. I just need it to be able to pick at different points in time, depending on where it is in its state. And so you can chain a bunch of things together. So over here, function node runs again, decision node runs, and you can run multiple nodes. You can run one node. It's pretty much up to you how you want to connect it. Cool. So how are we feeling so far? Okay, great. All right. So we'll start getting into the coding pieces. We will head over to the repository and we'll get started. So what we do need to open is this unfinished examples, simple example skeleton. It is over here. I'll also zoom in a second, but before that, I'm just going to show you what we're building. I will also be doing live debugging on stage, so if something does go wrong, I will be in the pits with you. So on me. But this is essentially the flow we're building. We're going to be taking a user input, which is going to be a function node. We're going to have the user input is just what the user is giving into the entry node. The entry node is a function. goes on to a decision node to pick between what to do next. And then we've given it two different functions to use as tools. One is add two numbers, and the other is multiply two numbers. And finally, we want the output of either of those functions to be printed. So we have another function for that. So once you have the skeleton open, please raise your hand so that I know that I can start. Okay, I will give it a second. Do we need a couple more minutes? Oh yeah, so it is under source, under fantastic agents, and under unfinished examples, and it's called simple example skeleton, so that you can fill it in.
Oh, I thought.
Oh, we're going to be writing those. Oh, if you do want to see it, it's under simple example arc MD, but it's in Mermaid, so you will need a renderer if you want to see it. Okay, everyone need another minute or two, or are we good to get started? All right, starting, yes. Okay, cool. All right, so now the fun part starts. Do let me know if I'm going a little too quick, because I will slow down and we can figure things out together. So the first thing I want to show you guys is what is the output we're expecting. So you can also try this and see if everything is set up correctly. There's one change that you'll need to make if you are using Grok, which is we'll need to go to simple example finished. And on the decision node, we're going to swap this out for Grok / I will need to look it up. So if you are using Grok and you have the API key in your environment, you can swap this out in the finished example. We're just doing this to make sure everything is set up correctly and to also give us an idea of what we're building, and then we can proceed. I will also leave this up on Asm Coding so that you guys can see it. I hope it's visible. If not, I will read it out again. So what we're doing here is we're going to run the function underneath. So I'm just going to run this. Tells me a bunch of things. So what's essentially happening in the background right now as things are compiling is it's spinning up these JSON for you under a folder, essentially. We'll get to it in a second, but you don't really need to worry about it as much as we're running this example. And this entire thing is about either being able to multiply numbers or add numbers. LLMs aren't always good at arithmetic, and they often mess things up. And that is also another reason why we want to give them direct Python functions to operate on. And what's happening in the background with these agents is that the LLM is essentially picking the parameters to run on your next function. So because we need to now test and see if things work or not, and they do often fail as well, because with LLMs, they do have their mind of their own, so they can pick any random thing at any given point, but we try and make it a little bit better. So I can ask, 12 plus 5. Very simple. We can see in the background what it was running, and the output is 17. So great, I am glad that worked. But we can also ask something a little bit different. We can say I have 6 goats and 2 cows. How many animals do I have? And it should still be able to grab the right parameters and the right things to pick up on from natural language to be able to operate on these things with pure math. Cool. This is just to get us running. Is everybody able to run it and see that it actually works on their machine? Yes, no? Oh, do you guys want to see the model again? It is this. So just like write it down because we'll need it. But I will also just copy it and bring it up when we need it next. Yeah, so you do need that API key exported onto your terminal or whatever environment you're using. So export and then export Grok API key and then whatever you want here. Or not whatever you want, your API key should be going in there. Cool. Okay, so we're going to get started on the actual coding and we'll tackle problems as they arise. So we're going to open the skeleton now, and you do want to follow along for this portion because this is where things get fun. I would recommend enabling logging because also add the import of logging just up top. It's built into your Python, so it doesn't matter if you don't install it. Okay, so we're importing logging. We're going to uncomment these 3 lines between 6 and 9, or should be 5 and 8. And then we're going to continue. So add 2 numbers. I guess I already added the add 2 numbers. So great, you don't have to implement this function. Now let's do the multiply 2 numbers function. So I'm just going to remove these 2 lines. And it is as simple as Python makes it, A times B. And we want that returned. Also, if you are falling behind at any point or you're missing code, I would just recommend either asking a mentor for help or just looking at the finished example and just copy pasting it to get it running. Could you speak up? Sorry.
I just want to give a warning for now. Just stick with open AI right now. Because I tried to block it and it didn't.
Like it gave you the wrong answer?
Oh, it just doesn't run.
Did you get your API key and set it up correctly? Because if it's giving you a 4.4, I'm imagining that some other thing is wrong.
You have to configure other places in the Python file. That's
For me, if you want, I can take a.
Yeah. Yeah, appreciate that.
Open AI.
Okay. You don't have to use OpenAI. If you do run into issues with Grok, someone will come and help you. You just need the API key set up correctly with these words, Grok API key, and everything should work fine. I have spent a little too long testing this stuff out, so it does work. Okay, yes. Yeah, of course. Actually, if you want to just wait, we'll get to it in a second anyways. So now this is where the finicky stuff is because I wrote it, which is the previous output parameter. This is essentially when you are chaining an output and you want to rely on the output that you had previously, and you want to use it in any way, shape, or form. So over here is where kind of the interesting stuff is. And we just want to do print previous output. And what previous output is allowing us to do is look at the result of the node prior and pass that along to the current function. So when you have that parameter, your program or the agent essentially knows to give that next node its value. Cool. And then our entry function is very, very chill. We're just going to be returning. We're just going to be returning input. The reason I have this is you can have different kind of mutations here, mutations or changes. So you can actually operate on the input already and fix things or add patches or whatever you want earlier. So now we're going to be setting up our different nodes. So first, we're going to add our our add to nums node. So we're going to say function node, func equals add to nums. We're going to do the exact same thing for the rest. We're just setting up our different function nodes. So multiply to nums node, we're going to pass the function multiply to nums. And then same thing for pretty much the rest. Cool. I do hit tab a lot because shout out to Cursor and Copilot, I guess. And so I don't have to write a lot of code anymore, but please do follow along to make sure everything is set up correctly. Okay, so now is the fun part. We're going to be setting up our decision node. So this will pretty much just say decision node. Oh, great. Wow, I was able to even find that much for me. So the model is Grok / Llama 3 70B 8192. So when models are created, the 70B, 8B, etc. that you see are essentially the number of parameters that the model has. But those parameters also link to the size of the model and how many gigabytes it's going to be taking up on your computer. So the larger the model, the larger it's going to be, which is why we use these API keys, because it allows you to just use something else completely. And you don't have to worry about any of the other aspects. So next, you can also say API base is equal to none. You don't have to do this portion. But if you are using Ollama, you should be able to change this up. I'll show you exactly what that would look like. So under Dagent, there's an example here. So if you do choose to use Ollama, this is the line you would need. And this is available on the Dagent repo. So if you don't see it, or you're not using Ollama right now, but you want to later, that's completely fine. But these are the parameters that we need in our function or in our decision node to be able to run this correctly. Cool. So we have our decision node set up, but how does Python know what's next? Or how does the LLM know what's next? So this is where we define how these nodes connect with each other, or these steps connect with each other. So reviewing the little architecture that we had, we already have a user input, and we want it to enter into entry function or entry node. Then we have our decision node, and then we're giving decision node the ability to pick between these two math functions that we've written. So let's go ahead and do that. So we'll uncomment, and we're essentially writing dot next nodes, which is what signifies what is next. It does need to be within a list. And over here, we can say decision node. And as decision node, we do need to give it the two kind of tools or functions that it is allowed to use. So this is where add to nums node and multiply to nums node will come in. And we want both of those nodes to point to print results, so we're going to add that as well.
Got a question.
Mm-hmm.
So if you want to expand the next nodes, what are the additional capabilities you have? Like, because it's a list, I'm guessing.
Yeah, so basically the reason it's a list is because it essentially iteratively goes through and generates like a tool description, which I will show you. But you need that description to be passed into whatever model you're using to inform it of what are the parameters, how can you use those tools, and what is the output that the model needs to give in order to run it. So there's no expansion per se here. It does just need to be a list, that is all. Everything else is kind of just handled for you in the background. Okay, the next thing we need to do is hit compile. The only thing here I would say is you need to make sure your force load is equal to true when there's any kind of function changes. So you don't need anything here. It is defaulted to false. But let's say you change the signature of your function, you change what it looks like, you change what the input output is. There's no like automatic diff yet because I haven't written that. You just need to write it yourself. And so just do force load true. And what it's going to do is it's going to make calls to whatever model you've picked to figure things out and run it. If we do run into any errors here, we can also figure that out. We might need to make a small edit, if I'm remembering correctly, but that's okay. That's the power of live debugging. Okay. Next we're going to do is hit run on the nodes. And we also want to pass in the user input. So I can put that in a while true loop. Hit user input equals this. And it does need to be the same as what I had here. I'm going to change this parameter user input. And then you do have to run it with quargs, which is your keyword arguments. So you do need to say user input equals user input. So it understands how to map those two things together. My gut feel says I forgot something. So when you guys do hit compile, we might run into an issue. But that's okay because we're going to go into the source code and fix it. Cool. So now we're going to run this code. Should be finished. I can say Python full example skeleton. Oh, yeah, let me reset these things that did get generated earlier. You're also going to run into random model issues, as we're seeing. And this is kind of the fun part with using different models. And sometimes it'll literally just be running it again and again and still failing. So there we go, it ran. And I didn't change a single thing. I just ran it again and again. Grok is a little finicky. If you do run into issues, you can default to Ollama or an OpenAI key. For the rest of the presentation, I might actually just swap back to an OpenAI key just to give an example and actually get things done. But if it doesn't work, that's fine too. Like we can use Ollama as well. Cool. So now everything should be set up correctly, and I will run it with 2 + 5. And it did not do anything for it. Great. Oh no, it did work. Sorry. There's just a lot of debugging happening. Can change that too. And then we can also do the same question. I have 2 goats and 3 cows. How many animals do I have? Okay, so this is an error you're going to run into from Dagent, which is good because what this is saying is that we passed our information onto Grok, and Grok wasn't able to decipher what tool to run next, even though we've given it a description. So when you hit the compile function, essentially what's happening in the background is you have this tool_JSON file or a folder, and these are getting generated behind the scenes without you having to do anything. So this got generated in the background where we didn't really have to worry about what was happening, and it just kind of did it for us. And this is what we do need in order to give the model the correct amount of information to work off. So because Grok is being a little silly, I will honestly show you the Ollama example because I feel that that one is pretty fun too. And so I'm just going to copy it. You don't have to do this portion particularly, But if you do want to like actually run the code and run it, I would either recommend that you swap to an OpenAI key or you use Ollama because you just want everything to be standardized. I would not recommend mixing of models as much, especially on the tool use aspects, because it may or may not give you inconsistent answers. So I'm just going to keep force load equals true, and I'm going to add this portion here. So Ollama is essentially a local LLM runner. So you download it and you can run models off your command line. We're not going to dive too much into it, but essentially we should be able to run the exact same thing and have everything built out. Never mind. Let's see what is up. Oh, yeah, I see the issue. I forgot to give it the parameter name. I did tell you guys I was going to be live debugging, so I hope you're enjoying me struggle. Sorry, say that again. What about it?
Like I have emptied the API key and I've also used to change the Python. However, it still doesn't work.
I would honestly just swap. If you're having like so many issues, I would stick to either OpenAI or Ollama. From all the testing I did, I found Grok to be the finickiest, but also like one of the easiest API keys to get. So I just kind of stuck with it. And then we can do the same thing and add a number. So I can say I have 3 goats and 2 chickens. How many animals do I have? And so the thing about Ollama is that it's not hitting any external API. It is literally all on device. So it is running off my MacBook and the model is a lot smaller too. I love the Ollama guys. They do a lot of really, really cool work. And I would highly recommend you check their stuff out. I can also just like ask 2 times 10 and hopefully it'll give the right thing. Nice. Because it's able to pick out the correct arguments for the function to be run with. Cool. I'm going to skip over this portion now. Any questions so far that are like very urgent? Are you able to get it running? If not, maybe get an OpenAI key if you're getting like Grok related issues. Any questions so far? How are we feeling? Yes, question.
Is it supposed to generate the tool.json before it starts running the code?
I didn't catch that last part. Could you be a bit louder?
Is it supposed to generate the tools before it starts running the code?
Yes. So when we hit this compile function over here, that's what it's essentially doing. I hated writing these little, I hated writing these JSON because that's how you were giving information and passing it into a LLM. But the issue is that it needs to be a certain format, it needs to be working. So I just abstracted that all away so that you as the user don't have to think about doing all this nitty-gritty work, and you can just kind of dive into writing code. And then the other aspect, same thing happened for multiply JSON, and all of this is happening on device, by the way, because we were using Ollama, which is pretty cool. Okay, that was a simple example. Because we don't have as much time for the complex example to like actually write it, we have about 10, 13 minutes. I'm going to go over the example. Yeah. Yeah. You know what? I feel like that would actually be a really cool thing to do live. So let's just do that. And I think that would be a good use of our time. So how does divide sound? Is that okay? Okay. To keep it simple. Divide 2 numbers. And so it's just A over B, and a simple function to divide 2 numbers. Cool. Yeah, it's fine. That's whatever. I use cursor, so I am too lazy to even do that. I can just say make into floats, and it'll do it for me. Great, yay. Okay. And then, so if we were making these updates, we'd want to add it around this portion where the decision node is able to pick between the user input. So we can just say divide to nums node, function node, func divide to nums. This looks good. And that's kind of it. The only thing we need to add is divide to nums node, give it to the decision node to say, okay, we have this node, but this is where it fits in our diagram. And then we also want the result to be printed. So now I can run the exact same thing. I actually don't have to run it with true anymore because I haven't made any changes aside from a new function. And it'll already recognize that the new function does not have a signature associated, so it'll go and generate that for me. So I can say 10 divided by, okay, sure, by 2. I have no idea why that happened. Oh, because I gave it a little, hold on, and divided by 2. I think it used the little square bracket as a thing. Oh, and it called the wrong function. Very cool. So this is where we're seeing like things can still go wrong with agents because you're giving a lot of context to our, oh, maybe it's not just, oh, was it running the wrong one? Yes, I was just running the wrong one. My bad. This is simple example finished. That is better. Oh, nice, 5. That was quick. Cool. And we can also see that in the background, it added this little JSON so that I don't have to worry about it. And it kind of just does its thing. So there is more setup involved with the browser-based stuff. So browser-based is essentially a headless browser that runs in the cloud and you don't have to worry about it. And it kind of just does its thing. And you can use Playwright, which is an automation library. The only thing you need for browser-based, if you do want to sign up, I can get you 1 month free if you use the code devtools, all caps. I think it's somewhere in my hack pack. If not, just text me. Cool. I'm going to run the finished example, but I am not going to live code it because we are out of time pretty much. But it is pretty cool. And I do want you guys to see like what are some things we can build with it because it's pretty neat. So you can also just follow along with the finished example or just look up here and see what I'm up to. So I do have logging enabled here. I have run exa function. You can also get exa API keys. Exa is essentially a search tool built for agents predominantly. We can actually go to their website, exa.ai. They do a lot of really cool work. And essentially, if I say use exa search, I can say AI companies, for example. And it's able to get like very, very particular examples and find like this web very deeply for whatever you need. But essentially, we're using that as a way to do searching instead of like Google or whatever. I have a structured data function, which does a bunch of different things. Entry, similar to what it was before. And I have like, this is where I have an extra mutation to enhance the query. So I was getting poor results. So I decided to add a little extra something into the input. And then we have the summarize final output function. And then same thing, we linked a bunch of the nodes together. And we're running a very similar while loop to like get user input. But essentially, if we are to look at what the diagram is, it's going from our entry node, it makes a decision, and essentially it's able to like chain a couple of different functions together. I run this exa node. I'm using LLMs to structure this data in itself. We have browser-based node, which spins up a whole browser and runs in the background and prints a final output. And a browser-based node is also actually doing some LLM structuring. Cool. So I'm not going to dive very deep into the code, but I will dive into specific pieces that I feel could be useful. The first thing is, again, you need to have your previous output. If anything is going wrong, just do ** quargs and you can print them and see if extra things are getting passed in accidentally, and that's causing issues. If you're getting like weird library errors, I would keep logging to debug. It is going to give you a lot of debug commands, but it is helpful, especially when you're debugging your tool use. Aside from that, this is the next most important thing I can tell you guys about using Dagent for data structuring. So it's just calling an LLM. This is not very like particular to Dagent, but I would highly recommend using response type of JSON because you're able to like structure data very, very nicely. So a very big powerful use for agents and LLMs is that you're able to go from something that is completely unstructured to something that can be consistently structured for your data needs. And this is done through prompting. So over here, you can see that I created a little format for my data, and I want it to be done in this format. So I like prompted it. So I said, okay, structure this raw content, make sure it is this, and then basically just turn on JSON mode, which is type response format should be type JSON object, and et cetera, et cetera. Okay, I do really want to run this. So I can ask it to do two things for me. I can either ask it to do like a simple search and structure that data for me, or I can ask it to go and scrape a website for me. So I can actually go and say, what are the hottest, or what are the, do we have a search? Actually, I can just say, what is Hack the North? So because it's in debug mode, we can see exactly what tool use and arguments it's using. So it said it found run exa to be the goal of the tool, and the query is Hack the North. So that is good. So because we're in debug mode, I will say, do I want to proceed? Yes. And it's like going to go do its thing now. This is in particular giving me an output in structured data exa. Going to take a second. I was looking at some other stuff earlier. But essentially, it's going, searching, getting that data back, and then structuring it through this, where to go? The structured data function. So this was like the raw data that we got back, and it's doing its thing in the background. Sweet. And we can see that Hack the North, and we were able to find a bunch of different like websites around that. So Medium, very old Hack the North website, and so on and so forth, which is pretty cool. I can also grab this link, or I can say Hack the North, for example, and I can say scrape website for me. And I'll go also do its thing. So it said, do this, and it said, okay, it found that it needs to use browser-based runner to do the scraping. I can hit yes. And it started doing its thing. It's going to take a second. We can actually go to the browser-based website. I can sign in. And we can see that if I go to sessions, maybe it's not spun up yet. I'm waiting. Oh, there we go.
I have a question. How does the model know which function to call? Like when I say add reply.
So how does the model know which function to call?
Like
Well,
the string of the model that has like a comment for the function to do, is that like you have to write that in?
what does the model do?
If you turn a function into a node,
Yeah.
you not write that string, if this function does this.
It is helpful, but see, this tool JSON is essentially getting generated in the background. So add two numbers got this, right? So you were able to say, this all gets written for you. So you don't have to write a doc string explaining what this is. So if I go into, because that's what like the library is taking care of for you. So usually you'd have to write all of that yourself. But what the library does is it looks at the function signature, like it looks at the actual code. It says, okay, this is the code. I need to convert it into a description from like a JSON description of this code. And so a model takes care of that for you. Anyways, it's pre-prompted, it's in the background, it's already happening. Yes. Cool. All right. So how are we feeling so far? Because we are at time. So we will end off here. Play around with different things. If you do want to use the complex example, I would say you can use it for either running it and experimenting, or you can use that as an example for whatever else you do choose to build. My opinion is that you can structure things extremely easily. And oh, I know I'm about to pull my Twitter up, so maybe ignore it for a second. But there's like something interesting I built a while back. So this was actually all built through Dagent, which is I built a little thing called Calendar GPT, and you're able to interact with full APIs through just natural language. So I did the exact same thing. I just set up different Google Calendar functions in Python. I gave them to Dagent. I said, okay, go do your thing. Go set it up for me. And yeah, and it just did, and it kind of just works. Cool. We'll probably chill over here. I'm gonna hang around for a bit, either in here if they let me or outside. Come see me if you have any questions or you just want to talk. If you have questions about Dagent, what you want to build, or I don't know if you want like internships or something. Not for my company because I'm not hiring yet, but other big tech internships because I've done the route. I did a chunk, and so I can probably help you around there too. Awesome. Thanks, everyone.